Alright, so what we got here is a Yale MPW065, basically a walkie, basically. So, complaint from the customer is it's an intermittent code 13 and code 42. So let's key on, see what happens here. Code 13. So what I found is if I key on, cycle the key maybe 3 times, it's gonna go away. Code 13 again. So wait one more time. Okay, so it's gone. All right, so now the code is gone. I can go down. Everything works normal, no code, 71% on the battery. All right, so let's try to drive. Moving forward. Okay, brake release. Run, no problem. Go back, no problem. All right. Okay, neutral, then go back. This is what's gonna happen. A code 42, right? So what's gonna happen again is you key off again, key on. Code 13 again. And they have to cycle the key a couple times. Code 13, off, on. Code 13, on again. Okay, so code goes away. Again, it would run, no problem. All right, until you stop. And then again, code 42. But once you get that code 42, you key up, you key on, it's going to be a code 13. Okay, so we looked up the 2 codes, and one is code 42, and it's saying controller is sensing voltage above present value. Also code 42 is controller is sensing battery voltage below a preset value. And then the code 13 that comes up, an external short on the traction motor, the M negative to the B negative. All right, but what's being said on the motor, possible causes: incorrect traction motor wiring, traction motor shorted to frame, M negative short to controller, which in my opinion, if this is what's wrong with it, that the traction motor has a problem, has a short, then that code would never go away. It should always be there, at least in my opinion. Now the code 42 is, remember, code 42 happens after we stop driving and we put the tiller head back and the brake disengages, right? So it's either going to be a controller sensing voltage above the present value, or a controller sensing battery voltage below a preset level, right? So one thing we know for certain is the code happens after we put the tiller hand back to neutral, right? And the brake disengages. So I'm not going to look towards this, not yet. I've already checked the battery voltage and there's nothing there, all right? But what I want to check is what happens to that brake when it disengages. Okay, right now, so I cycled the key 3 times again or so that we don't have the code 13 again. So right now I got my blue trace hooked up to the negative part or the control side for that brake assembly. This wire is going to be the positive supply, and this is coming from the computer. This is supposed to be provided negative by the computer to operate that coil. Okay, so channel A, I am going to focus you on the screen. Let's play this. So it's 0 right now. No, it's actually 12 volts, right? So when I put the tiller handle down and try to drive, I'm expecting to see 0 on the trace because it's going to be provided in negative by the computer, right? But what I'm interested in is when we release it. Okay, let's try right now. Try to drive, drop down to 0. All right, so we're driving, then we release it. There. And then soon after, code 42. All right, so let's pause this. And let's play it back. This is my concern. This spike coming from the coil is reaching 60 volts. Let's zoom in on it a bit. Zoom on this part. All right. 60 volts when you turn it off. Well, that is a coil. It's an inductor basically. When you try to take the current out, it tries to keep the current going, so it jumps up to 60 volts. So my thinking is this surge of voltage is kind of like going through the computer and corrupting it basically. So when I look at the diagram, right, and I notice that, see these two metal tabs here? There was supposed to be a diode in between these terminals to prevent that spike. All right, and so what I'm going to try to do is, I already got the diode, right, and I'm going to plug it in here, and we're going to do it again and see if anything changes and if we get the code disappear. Okay, that's what we're going to do next. So cycle the key again to make that code disappear. So I just same setup as far as oscilloscope is concerned. All right, so I'm going to focus you on the screen again. Let's play this. Okay, that's live. 12 volts. Go down. Try to drive. All right, and then release the brake. Okay, look at that. And no code. So I should have coded already. Go back down again. 71%. Release it. And no code. All right. So what's happening is the inductive kick from that coil is basically, what I'm thinking is, making the ECM or the computer shut down momentarily. It doesn't know what it's doing. It's backfeeding back to the controller. It's a good thing that we didn't burn the controller just quite yet. So it's just a quick fix of replacing that diode, and there we go. So we're going to be doing a little bit of study and try to figure out why we have a code 13 whenever that diode from the brake assembly is removed or broken or open. So right now I key on. So my red trace is going to be my battery voltage, and the blue trace is going to be the voltage from negative, from the B negative up to the motor negative. So it says here a potential cause is the voltage, and this is how the computer checks it. Verify that the voltage between B negative and M negative to be 10% less than the nominal battery voltage, and if it's greater, replace the controller. So my thinking is this, because these controllers have a capacitor inside, right? And what I'm thinking is, when you have the inductive kick, it either drops it down or charges to more than the preset value. So this is what I'm going to do. Right now we have battery voltage, which for sure is going to be less than 10%. So right now voltage from M negative to B negative is 9, which is less than 10%. So I'm going to try to run it and see the reaction. Okay, it charged up to almost battery positive. Main contactor kicks in. So let's run it. Now I'm driving. That's the noise. I can hear it. It's running. Right? Let's wait for another frame. And then off. You can hear it clicking, so that releases the brakes. And of course I don't have any code, but it stayed at almost battery voltage, which is 12.8. So it should never reach the voltage from the battery. My thinking is, if it reaches voltage from the battery, that means to say that the capacitor already shorted. Okay, now I'm going to try to take away the diode and see what happens. Okay, diode is out. Handle goes down. Try to drive it. Let's wait for another frame and see the reaction from M negative to B negative. Okay, release it. Okay, so now it dropped to 0, and of course there's a code 42, right? And then you key off, you key on, and of course you have a code 13. But you can see the voltage has dropped down to 0, but it is slowly rising. So right now it's at 1.6, but you can see it is slowly rising. And of course, I'm thinking once it reaches that threshold for the computer, the preset value, once I key up and key on, then it would not have a code again. So I haven't keyed up yet, right? I'm gonna wait for it to charge up the capacitor, and let's see if I key it on, if I am gonna still have that code, and if it goes away. So right now I am at 3.3 volts. A little higher. It's still rising, but you know what? Let's see. Key off, key on. All right, and the code is not there. Okay, so the theory I think is correct. So the computer checks for a certain voltage between the M negative and the B negative. Now it has a threshold, either lower than the battery voltage or higher than the preset value. So once it reaches that threshold, above and below that threshold, you're good. So you consider it as a good startup. And that's the reasoning, at least in my opinion, and why you have a code 13 and you key on and key off a cycle a couple of times, but actually you can key up and key on and just wait for it to charge to a certain threshold, and the code would go away. Also the code 42, I'm thinking because at that moment when the brake kicked out, you see higher voltage, right? And that's why it's code 42 after the brake is disengaged, and then you see a code 13 after key on. And if you key on right away and it hasn't reached a threshold yet, then that's what's happening. Okay, I hope this is a clear enough explanation on why potentially this code is happening, code 13 and code 42.